Question 3c. A ferry wharf consists of a floating pontoon linked to a jetty by a 4-metre long walkway. Let h meters be the difference in height between the top of the pontoon and the top of the jetty, and let x meters be the horizontal distance between the pontoon and the jetty. Part 1. Find an expression for x in terms of h. X and h are the two short sides of the right-angled triangle. So by Pythagoras' theorem, x squared is equal to 4 squared minus h squared. And of course, 4 squared is equal to 16. Taking the positive square root of both sides, since x represents a distance, x is equal to the square root of 16 minus h squared. Part 2. When the top of the pontoon is 1 metre lower than the top of the jetty, the tide is rising at a rate of 0.3 metres per hour. At what rate is the pontoon moving away from the jetty? Apply the chain rule, as this problem is based on related rates of change. dx dt, which is the rate at which the pontoon is moving away from the jetty, is equal to the product of these two related rates. That is dx dh times dh dt. And dh dt is the rate at which the tide is rising with respect to time. We'll call this equation number 1. Now when h equals 1, dh dt is equal to 0.3, and that's given in the question. So we need to find dx dh, and we need to find the value of dx dh when h is equal to 1. So we need to differentiate x with respect to h. Now from part 1, x is equal to the square root of 16 minus h squared. But before we differentiate x with respect to h, we need to express the square root of 16 minus h squared in index form. So x is equal to 16 minus h squared, all raised to the power of half. Differentiating x with respect to h using the chain rule, we have dx dh is equal to half times 16 minus h squared to the power of negative half multiplied by the derivative of what's in the brackets, which is negative 2h. And that's equal to negative h over the square root of 16 minus h squared. So when h equals 1, dx dh is equal to negative 1 over the square root of 15. Now from equation number 1, dx dt is equal to dx dh when h equals 1 multiplied by dh dt, which is 0.3. And that equals negative 0.0774596 and so on. Now as the tide is rising, x increases as h decreases. Therefore, dx dt is equal to positive 0.077 meters per hour, correct to 3 significant figures.